So we've already alluded to these issues of how do we manage the data. A lot of us are currently aggregating data either by, if we're lucky enough to have a fat pipe to the internet, we squeeze it through that. If we're not, we FedEx large lumps of hard drives and so on around, which is not an ideal solution at all. And we are worried about the data security issues of doing that sort of thing and the consent that we've already talked about. So how do we analyze each other's data? How do we federate our access to the data? And that's what the next part of this session is to talk about. And to chair it, we've got Dan Bedard from RENCI, who in the University of North Carolina, who most of you will know is the home and the origination place of iRODS, which is a data management system that some of us are using. I want to stress that I don't particularly want this to become a purely iRODS discussion. Other data management tools are available, so we should, but this is over to you, Dan, really, to chair this discussion of how we deal with this sort of thing.
I can guarantee that this is not going to be completely iRODS specific. So, really, I'm going to ask a lot more questions. But first, let me talk to you about iRODS. No, so iRODS is open source data management software, and it's regulated or overseen by a consortium of 12 different members from industry and government and academia as well. And the Sanger Institute's one of our members. DDN is one of our members as well. And I'm going to talk a little bit about some of the problems that we've seen, but really I'm going to ask you more about what your experiences are and if you've seen some of the issues that we've seen and how you've handled them. For me, this is kind of a way for us to get some free market research to find out what you're up to, what your problems are, and really, because we're this open source consortium-based software project, we want to find out how to address those problems in a collaborative way. So speaking of problems, I don't know if you've seen this article. This was from, I think, June or July in PLOS Biology. There's this study that's done that compares different big data domains. And so they looked at astronomical data, compared it with Twitter and YouTube, and then compared it with genomics data. And they compared it on 4 different axes. They were looking at acquisition, storage, processing, and distribution. And really, genomics data blows away all of the other big data producers on all 4 of those axes. So Alf and Jürgen had mentioned personalized medicine. When we get to the point where we are sequencing, in this article they estimate 25% of the human populace throughout the world, and that's billions of people. They're estimating that by 2025 we'll be producing between 2 and 40 exabytes of data a year with genomics data. Which, when I first read this, I was thinking, oh, 2025, that's way off into the future. That's only 10 years. It's funny, every time I look at a date, I'm thinking it's way further off into the future than it is. But yes, 10 years from now, 2 to 40 exabytes of data per year, it's looking very good for DDN and the people who need to be able to store that data. But we're also beset with problems, and I thought this was a particularly funny picture, considering that Jonathan later on will be leading the Birds of Feather session. Jonathan's with Google Genomics. I really hope this isn't true, as it says on this slide. But this was really just to cover the point of this talk. Since Google doesn't have all the answers, I'm really asking you for some of your answers, some of the approaches that you've started to take, some of the things that you think are finished, and some of the things that still need a lot of work, both in data management and in terms of your overall pipeline. Again, our previous speakers have mentioned that the algorithms haven't even converged yet. And so I'm looking for hints as to where the puck is going. It's a hockey reference. And just to prove that we don't have all the answers, this is from an installation that we have actually running right down the street from us at the Lineberger Cancer Center. This, let's see, up at the top, this is a file name. And this is one way that metadata is being managed. And this is in an iRODS system, which has metadata management capabilities. But you can see actually we're in this file name identifying the processes that have been applied to the data, the sequencer lanes that were used. There are better ways to do this. And so what I would like to know is what you're using to manage your data and your metadata. How are you tracking what processes have been applied to the data? And I'm going to look for hands. Yes? Oh.
So you suggested that or you made the comment that, you know, for heaven's sake, the algorithms haven't even converged. Now, I would postulate that given that we're in a very much an R&D and a scientific context here, that the last thing that is likely to happen is the algorithms ever converging from an informatics perspective, because that's what we're all busily beavering away on. So I'd say that what you need is the flexibility to adapt to new algorithms, to adapt to new reference genomes, to adapt to new ways of processing, analyzing, interpreting these data sets.
So does that mean that you plan to hold on to the raw data for an infinite lifespan, or?
That's a very interesting question, but I would certainly say that there are so many aspects to this. I mean, one of the aspects is that cells, DNA, are a very, very optimized storage medium for sequence data. So you could get to a situation where the sequencing is sufficiently inexpensive that the best place to keep your DNA is in a biobank sat in a freezer somewhere. And if you need to get the DNA out of that, then you sequence it if the sequencing is sufficiently inexpensive. Obviously, we're a long way from that, but that's one potential.
That's a good point.
At the moment, talking about moving from FastQ files to BAM files and saying, we don't need the FastQ files anymore because we've got the alignments, and then to CRAM files, so we don't need the BAM files anymore because we've now got reference. We've got compressed alignments. I would say that actually very, very soon we are going to want to realign all of the genomic data that has been collected in the Cancer Genome Atlas, International Cancer Genome Project, the 1,000 genomes, the UK's 100,000 genomes project, is all going to need to be realigned because we're moving more towards these graph-based assemblies, and we're going to want to revalidate our findings that we've been made over the last 10 years or so. So I'd say certainly now, yes, we are going to need to keep the raw data available so that we can realign it.
Sorry, and I'm just going to ask, could you introduce yourself, even though it's after the fact?
Okay, so I'm Will Spooner. I'm an ex-Sanger/EBI person. I now work for Eagle Genomics, which is a company I founded about 7 years ago in bioinformatics.
Okay, thank you. And then if you could introduce yourself.
Hi, I'm Rob Tesnoff, Wellcome Trust Centre for Human Genetics, which is University of Oxford. As one of my guys was the lead, or one of the leads on the 1,000 Genomes project, I know that is beginning to become a kind of a marginal data set because the coverage is low, the quality is low. That is, a data set that's still useful but is beginning to fall off the radar. People are doubting whether I should keep it on fast disk anymore. There is always a AIM somewhere, but very few people want it anymore. They want to move on to the new stuff, which is better.
And
yes, I'm Laura Clark. I run the data management for the 1,000 Genomes project. Quick note on that, 1,000 Genomes will remain valuable because it's the only public data source available. Everything else you have to jump through hoops to get. This is going to be a challenge. This is always going to be a challenge. One of the things that will be interesting if we move to graphs, you stop seeing new observations at a certain point. If you've sequenced 100,000 Brits, you're not, and 100,001 Brits doesn't add that many new observations. So when we move to a point where, and we have to figure out how to do it, where you don't have to store the raw data because You just have to store the small amount that is different from the new observations versus what you've already got. And again, how that's going to happen and who's going to solve the problem of actually getting all this data into graphs rather than linear bits of sequence, I don't know. But that is one way this is going to go, and the human reference is already starting to move in that direction with the alt haplotypes. But it's still a linear reference, and of course, once we move away from it being a straight line, how do we actually make all the assertions that we currently make in straight line coordinates?
And how are you attaching those assertions to the original data set?
So I mean, that's metadata is the other challenge. Is actually how do we know who we've sequenced, when we sequenced them, what we knew about that individual when the data was collected. And I'd actually argue that good quality metadata is a greater challenge than good quality sequence data at this point.
Agreed.
And a slight note on that, Robert Davey from TGAC, I like to requote him as saying, any metadata is better than no metadata. So obviously good metadata is even better yet.
Cool.
I refute that any metadata is better than no metadata, because some metadata is so bad to be misread.
Okay.
Well, I think I put these slides in order of most challenging to least challenging. So this is probably the most challenging problem that researchers are facing today is how do you annotate the data in a way that's meaningful, in a way that's uniform, and I'm certain that that will be discussed this afternoon as well. And then how do you associate that metadata with the data itself?
I have a question, and this kind of ties back to the morning discussion and questions around Alf's talk and so on. So we were talking about IRBs and consent and all that. What's best practice on that? Is that just tagged as metadata onto the data set? That they have consented to this, or how is it a separate database, or how is that kind of stuff done? And I'll hand the mic to Alf to answer, but other people might have a better answer.
Well, it goes back to this identity management system. Ideally, you have the consent tagged with the same ID that your data is, and then you have the reference through a data warehouse or something. So yeah, essentially it's metadata to your data.
Is that held in like a relational database, or is that a really big spreadsheet?
Depends which hat I'm wearing to answer this question. At MDC, actually, for the gene sequencing, we are tiny compared to Sanger and Heidelberg. So it is an Excel spreadsheet. Yeah, we are about to change that, but it still is. For the BIH, though, the gene sequencing core facility is looking. So all the machines are from Illumina. And Illumina purchased a company that does kind of a LIMS and automatic workflow system, where you can store a lot of metadata inside that whole workflow system, and we are purchasing that to keep track of all our data. And then that then gets, I mean, I don't actually know, I think it is a relational database, but it really doesn't matter that much. And our central kind of data warehouse is SAP HANA, so that's a column-based storage.
Comment over here.
Hi, I'm Hanif Khalek from Weill Cornell Medical College. So we actually we also have a very low throughput situation, but I'm not sure how it is in terms of data ingress. Is like when someone hands you a request, for uploading data. I think this is actually where we tend to do our manifest. So we basically tell them we're not uploading the data until we see a manifest. So it's easy when you know the people. I mean, if you have like 1,000 customers, I don't know. I think you can still do it. It's just harder to say no. But when they hand us drives or they ship the RAID, the RAID unit with the data from the sequencing, the partner, or let's say even just from the lab, then we say, okay, we're not uploading this into.
Oh, right.
Oh, that was a.
Seems to be an annual tradition whenever I'm in the UK.
I don't know if what I said was insecure, but so anyway.
I think I saw something about a drill. On the,
I was not expecting one.
What does that mean?
All right. I'll go check what's going on, and you guys continue unless I come screaming into the room.
Or unless we start smelling smoke.
So last year we had a joint workshop with DDN as well. This actually at UCL, and And the fire alarm went off in the middle of my discussion again. So hopefully next year we can repeat this. No, but I think Hanif, your point was a good segue into this next one. If people are handing you manifest files, how are you making it so that the data is discoverable once it's in your system? So are you indexing those manifests? So you're storing them in a database and then...
MongoDB, I mean, we just basically have a place to put them. So then we worry about what do we do with it because we don't know.
Sorry.
So again, this is something that actually does scale, which is you just put it in a very simple, almost schemaless kind of data store like MongoDB, and then we have the file names because we put them where they need to go, and we have a manifest that allowed the customer to expect the files to be somewhere, and then all the clinical, the federated identity management all goes from there, because in some ways the lab is sort of really the data that's hard to understand. If you don't have metadata, it's like useless. Whereas in clinical, there's lots of sort of self-identifying information that you have to hide. Whereas genome data is only self-identifying to the rockstar bioinformatician. So.
Sure. How else are people using metadata? So are you able to run reports? Are you able to do chargeback analyses for IT services based on the metadata that's stored in the system?
I'm certainly not doing that with. Right. I'm certainly not doing that with sequencing data at the moment, although it's something that I'm going to be looking to do as certainly as the Wellcome Genome Campus expands. We're going to be providing services to other people much more than we currently do. Currently, it's pretty much all for ourselves, but the future is definitely going to be measuring exactly how much people are using across the board, not just with the sequencing data. So,
and then do you have plans to audit the sharing that you do? And I don't want to get too far into sharing, but
I think plans is probably too strong a word.
Vision?
At this point, yeah, vision.
Does anybody else have any other comments on how they're doing data discovery?
So Will Spooner again. So I think it makes a very big difference whether you're doing data discovery within a single organization within a single IT system, or whether you're doing data discovery across a consortium like a hospital versus university versus research institute versus something even bigger across, including public data sets and other places as well. So I think the question is probably fairly much is probably fairly complex.
I think you were maybe first.
So yeah, Laura Clark. So we're interested in data discovery from a user perspective. So we manage large scale data sets for big projects, 1,000 Genomes, Blueprint, HIPSCI, other large genomics and other projects, and actually making sure that anybody in this room or anybody in any institute around the world could find it. And I think what was said about, yes, schemaless databases, well indexed, we're looking at Elasticsearch at the moment rather than MongoDB. And then both building nice web interfaces so people can search them, anybody, your lab, wet lab biology, but also the advantage of things like Elastic and other things is they also come with JSON output and sort of built-in REST APIs, so the rockstar bioinformaticians can do it on large scale as well as just clicking through. And so this is really important from making sure everybody in the world can access data, but that everybody in the world is allowed to access. Of course, you can't. And then we've got the challenges of what we do about the data that has to be behind protected walls. So I don't know. People here probably know about the European Genome Archive, which is essentially the secure archive at the EBI to support storage of data that's only been consented for managed access release to bona fide researchers. And this is an interesting model because here the people who give permission for access are not the EGA, but the submitter. The submitter forms a committee and is actually responsible for giving access. So we run this service for Blueprint, which is a sort of a project being done on the epigenetics of hematopoiesis. And that's really quite challenging. We try our best to turn around responses in sort of 2 weeks, but we're having to get scanned forms with wet signatures on them because these are legally binding documents.
Yeah.
And I think this is a problem that the Global Alliance for Genomics in Health is trying to solve, but I don't know in what direction they're heading. So,
Thank you.
Yeah, I have 2 comments. One to explicitly this is what you have mentioned, Laura. Absolutely. So we also store many of our data sets within the EGA. And it's really fantastic that the PI has the permission to deliver the data. That's very, very good. What's not so good in the EGA is that I don't find my own data. So that's another story. But nevertheless, EGA is a very, very good approach. The second story is finding data is, as we are, and Berlin has the same situation, or also in other hospitals, if you make sequencing on patient data, that's another story. So in the moment to find, as I see this guy, to find, it would be difficult in the moment, so I could do it, but only because I know what's in the data. But it's hard to find, if we get 10 times more data, to find, for example, a breast cancer who has a KRAS mutation and an age of bigger than 20 or whatever. And I see, and in Berlin they have the same opinion, there's only one way, and that's a new 100 million investment, to bring the medical world and the bioinformatics world together. And we do it similar as Berlin does within the SAP data warehouse. And there will also be this big data warehouse will bring together the genomics data, not the data, but the genomics information and the clinical information. So, and the identity management is really critical, at least in Germany. So I don't want to put any hands on this, so I'm happy to give this away to the medical informatics. That's just a comment on this.
Within the UK, at least, there is a national project to try to coordinate the way we do federated access management, not just within life sciences either. So although there's a thing called the FAR Institute, which looks at the informatics analysis specifically of medical records, and they have a project using a new service that's come out from GISC, who are the UK's academic network provider. There's a service called Ascent. Was it Ascent or Assert? I can't remember which is a federated authorization protocol. So it's nice to see that the UK is at least trying to do some federated identity and access management. How successful it's going to be and how well it'll spread more widely than just the UK, because obviously we need to have global standards for doing this if we're really going to share data with each other.
Are you aware of this
IHE? No. There was one thing I was going to say regarding the metadata, which I think is quite important, is that there seem to be 2 levels of metadata. There's the metadata that we attach to the files themselves. That's relatively straightforward, and we at Sanger manage that within iRODS. But there's a higher level of metadata about the entire collections of data, which are probably what the researchers are really more interested in. They're not so much interested in the individual records. They want to know, is there a data set somewhere that tells me about such and such? Now, I'm aware of some projects that sort of are looking at that area, things like the Harvard Dataverse and solutions of that kind.
Like catalogs of catalogs.
Yeah, so I'm aware that you have some involvement with the Harvard Dataverse people. I mean, can you speak to the sort of things that you guys have been doing around that?
So essentially, we're making it so that Dataverse can access catalogs that are in iRODS and then index iRODS catalogs. So it's sort of using Dataverse for federation-like capability.
Does anybody else have any approaches that they're trying to that sort of thing?
So there's all of the Oxford eScience Centre. There's the ISA project, Susanna Sansomo, who was at the EBI, and that's about how you a more of a standard way of describing an describing an experiment, basically. So you just talk at very basic semantic levels. What is an experiment? An experiment consists of an investigation, which is the experiment at the project level. This is the project to do X, Y, Z. The experiment at the study level, where the study is the scientific question being asked, the hypothesis, and then the experiment as a collection of assays, which are the things that are being measured. So there are some efforts, and I'm sure that's not the only one, to enforce some sort of semantic consistency across how you describe an experiment, all the way from the investigation level through to the assay level.
So Genome Analytics, as you can imagine, is actually the idea of doing in situ analytics on genome files. And before I talk about that, I'll just sort of talk about where I am these days in Weill Cornell in Doha campus.